For this investigation, you're going to look at how the surface area or the amount of a block that is actually in contact with the ground is going to affect the frictional force that is acting on it. So your basic setup is this is the same block. This is going to be with the flat end down. This is going to be with the skinny end down. You're going to have a 1 kilogram mass sitting on either one, and you're just going to simply pull it with your force sensor. Now, how we're going to pull it is we want to pull with a constant velocity. And because it's traveling with a constant velocity, we know then that the net force is 0. So if we think about our block, right, we're going to have the force of gravity down. We're going to have the normal force up. You'll have it moving to the right. So this will be your force of the pull. And then our frictional force would be to the left. And because it's at a constant velocity, we are going to know then, based on Newton's third law, that the net force must be 0. So that's going to mean that our pull force and our frictional force are going to be the same. So essentially what we can say is that whatever our sensor is going to tell us, we can know that that is our frictional force as well. Now, for your sensor, you're going to get a graph that looks something like this, where this is my force, this is going to be time, and you might see kind of a big spike up, but then what we're going to be looking for is for, this is kind of what's going to happen for it to start moving, and then this is the value that we're looking for at a constant velocity. So when we get this graph, and we should see somewhat of a flat horizontal line, this is the value that we want to take for that.